Hello, this is Sharon Sarago, and we're going to start with circles on our online math course today. As you know, a circle is a set of points that are a given distance from a fixed point on a plane. The distance from the fixed point, called the center, to the circle is called the radius. So we have this fixed point right here, and from here over to either side is called the radius, and the whole thing there would be called the diameter. Radius is just half of it, diameter is the whole part of it. The diameter of the circle is a segment that has its endpoints on the circle and passes through the center of the circle. And as you can see, the diameter is twice the length of the radius, or D is equal to 2R. All of you already know all of this. There are many formulas that you may have learned about circles in geometry class, but there are only a few that you need to know for this test. One of them, of course, is going to be for circumference. The circumference of a circle is a measure of the distance around the exterior of the circle. Think of the circumference as the perimeter of a circle. And to find the circumference, there are two formulas you could use. Either circumference equals 2 pi r or circumference equals pi d. So here's a hint. When working a problem, use whichever formula is easier for the information given in that problem. For example, if the problem gives the diameter of this circle, you would want to use pi d. If it's talking about the radius, then you could use 2 pi r. Of course, you can always convert either way you want. Here's an example. Circle A has a radius of 4 millimeters. What is the circumference of circle A? Alright, so if we know it has a radius, and we know that our formula up here is 2 pi r, then it would be, of course, 2 pi 4, since the radius was 4, which would be 8 pi. Here's another problem. A circle is graphed on a standard coordinate plane and has the endpoints of its diameter at 4, -5, and 0, -5. What is the circumference of the circle? Anytime they ask you about XY coordinate plane, you have to graph that. You have to look at it. And every time you put down a point, you have to go ahead and write down the coordinates, because those coordinates are the things that we're going to be using. So the question here is, what is the circumference of the circle? Well, remember the formula for circumference is pi d. So if this was the diameter, that's what it says, it has its endpoints of a diameter at 4, -5, and 0, -5, then what's the circumference? This is the diameter. How long is it? It's from 0 over to 4. Here, 0 over to 4. And so, of course, it would be 4 pi. Another one. If the radius of a car's tire is 2 feet, how many feet does the tire travel after 4 complete revolutions? Well, we've got a tire. And let's say this is the ground where it starts. And, of course, that tire is going to go around 4 different times, just like that. So, if we want to know how many feet it travels, you would need to know the circumference for 1, the circumference for 2, because it's going to be moving along, right? It goes along here, and here, and here, and here. That's 4 times. So you find if the radius is 2, what's the diameter? 4. How do you find the circumference? It's pi d, so it would be 4 pi. But how many times around is it going to go? 4. So you would multiply the 4 times around times its circumference, which was 4 pi, and that would be 16 pi. Circumference practice. Another one. This looks ominous, doesn't it? But it really isn't. RT is the diameter of the striped triangle. So let's just look at here. Here I've left the R out. RT is the diameter of the striped circle, and it's the radius of the dotted circle. So this amount right here is both the diameter of that little circle and it's the radius of the bigger circle. If the area of the circle T, the big circle, is 36 pi square units. What is the circumference of this one? All right, so we know that the area is pi r squared, right? And here's our radius for that big circle, and that's what we're trying to find first. The area of it is 36, right? And so if the area is 36, then what would the radius be? Of course, it would be, remember, pi r squared, so what squared equals 36? It would be 6. So this whole line, which was the radius of T, is 6. And we're wanting to find the circumference of this circle right here. So what would it be? Of course, 6 pi. Now, we need to find area of circles. Area is pi r squared. Just look here, another important formula you should know is for the area of a circle. The area of any figure measures the number of square units inside the figure. There's just one formula for the area of a circle. You should notice that it requires you to use the radius of the circle. Area equals pi r squared. Here's an example. Circle A has a diameter of 12 meters. What is the area of the circle? All right, so if we go back here to the formula, area equals pi r squared, we know the diameter here. We're looking for the radius. So if the radius was 6 and our formula is pi r squared, that would be pi 6 squared, which would be 36. Another problem. In the rectangle shown, the length of the rectangle is 20. We have that. And the area of the rectangle is 120 square feet. If the circle touches 3 sides of the rectangle and is tangent at each of those points of intersection, what's the area of the circle? Well, I only know the length here. I need to know the width, right? So I know that the formula for a rectangle is area equals base times height, or area equals length times width. I can write this algebraically because they told me the area of the circle was 120 square feet. And if I know the length, I can just substitute those numbers here. And I would find out that the height here, or the width, either way you want to call it, is 6. So just notice, though, that this diameter, this length right here is the same thing as the diameter. And so now I know the diameter of the circle, and I'm trying to find the area. So what do I need? Not the diameter, because remember my formula is area equals pi r squared. I need the radius. So half of 6 would be 3. My formula now becomes area equals pi 3 squared, and of course that would be 9 pi. Here's another one. A bullseye consists of 2 circles with the same center. If the circumference of the outer circle is 18 pi and the circumference of the inner circle is 12 pi, what's the area of the shaded ring? Well, let's look at this. We've got a bullseye. We have 2 circles with the same center right in here. The circumference of the outer circle is 18. Okay? So remember, if your formula says that the circumference is pi d, then the diameter of that large circle would also be 18. The radius then would be 9, right? Now, I don't know that we're going to need that, but it's nice to just go ahead and think that through. And then the circumference of the inner circle is 12 pi. And so that would also be the diameter. And if we were going to find the area, we would know that that would be 6 pi. This says, what is the area of the shaded ring? So in order to find this, it looks like I'm going to know the area of the big circle, the area of the small circle, subtract those two, and then wouldn't I get the shaded portion right here? And that's very simple to do because we know that the area of the outer circle, the shaded one, is going to be pi r squared, and this was my diameter. We know that the inner circle is going to be pi r squared. This was my diameter. Subtract, go ahead and figure your area, subtract those two, and you've got that. I'm going to leave you to do the math. Another area practice, we have square WXYZ is inscribed in a circle. There we go. XZ, which is not shown, is both the diameter of the circle and the diagonal of the square. If the perimeter of WXYZ is 48, the perimeter of this right here is 48. What is the area of the shaded region? All right, well, we need to find out what this area is right here. So if the perimeter is 48, what would each side be? Remember, the perimeter is just 4 of these. So you'd take 48, divide by 4, you'd get each side is 12, right? So how am I going to find the area of this square here? Well, it would be side times side. Sometimes we say length times width, but on a square it's side squared because they're both the same. So again, I'm going to have to find the area of the big circle, subtract the area of the small square, and then I would have that shaded portion. Easily done. Alright, the last one, 2 identical isosceles triangles are cut from a circle as shown. If E is the center of the circle, what is the area of the unshaded region? Alright, well, we've got another kind of problem here. We've got isosceles triangles, so it's probably we want to mark these so that we know that they're isosceles triangles. And if we're trying to find the area of the unshaded region, we're going to have to know the area of these also, right? So how are we going to find the area of that triangle? Remember that for the area of a triangle, its area equals 1/2 base times height. I don't know what the height is. I know the base is 16. We can work on this one down here. Well, let's drop a dotted line down here. And now, instead of this whole base being 16, this part would be 8. That would be 10. What would this be? Do you recognize these numbers? You remember our triples that go 3, 4, 5? So what if I multiplied all of them by 2? Wouldn't I have 6, 8, 10? You have to have these things memorized, and you have to be able to recognize multiples. And so I've got an 8 and a 10, so I know that that is 6 because I've memorized it. All right, so now I know what my height is. I know what my base is. So I would be able to find the area of this whole triangle. But remember, there's 2 of them. So when you start doing your calculations, don't come up with an answer that just says 1 triangle subtracted from that whole circle area. You've got to have 2 of them. And then, of course, I already know how to find the area of my circle. You see this line right here, they said was 10, which was one side of that, but it's also the radius of a circle. And so I can go back to my formula, area equals pi r squared, and I'll be home free. All right, so now we've got to know something about arc measure. Now there's 2 things that we have to know about an arc. One is the measure, and the other one is the length for this SAT test. And these are the only 4 things they ask you. So on the old test, the new test is going to be a little bit different. So in order to find the arc, we have to find out what that angle is in the center. So the rule says whatever the measure of this angle is, it's the same measure as the arc. You see, if this angle were 50 degrees, the measure of that arc is 50 degrees. Now, people, the important thing to remember is the word. It says measure, because there's another thing that we have to learn about, and that's the length of it. So be sure you understand this is the measure of the arc. All right, so let's look at and see what it says here. In the circle shown, the center of the circle A and angle BAC shown inside the circle is called the central angle. Recall that a central angle is an angle with its vertex at the center of the circle. The measurement of angle BAC is 50 degrees, and the measure of the arc from B to C, shown as this little curved line over BC, that's how we'll read that, also has a measure of 50 degrees. An arc that has its endpoints on the diameter of the circle is called a semicircle. Of course, if we had the arc all the way around there, right, that semicircle would be 180 degrees. And an arc that has a measure less than 180 is called a minor arc. So this one right here would be a minor arc. It's less than 180. And an arc with a measure over 180 is called a major arc. So if I wanted to say the arc from C all the way over to B, you see that's more than 180 degrees, and that would be called a major arc. Let's see if we can work some problems with arcs, measures. In circle W, shown to the right, the measure of arc YZ, I see it right here, is given to be 75. If XZ is the diameter of a circle W, what is the measure of the arc XY? Right here. That's the one we want to know. How long is that arc? Well, we already know that XZ is the diameter, and we already know that that's 180 degrees. It's a semicircle. We were told that this much of it was 75. So just remember, it's the same as if I were just doing any kind of problem. If I know that this angle is 75 degrees, and I know that this whole thing is 180, couldn't I just take 180, subtract 75, and get my answer? And so that would tell me what this arc is equal to. Here's another one. Circle A, shown to the left, is intersected by an equilateral triangle. Here's my equilateral triangle intersecting the circle. If AB, right here, is 8, what is the degree measure of arc CB? So if this angle, this thing right here is 8, right? And they want to know the degree of that. So how do you think that we're going to do this? We know it's an equilateral triangle, so each one of these angles has to be 60 degrees, right? So if this angle is 60 degrees, what's the measure of CB? It doesn't make any difference that the length of that line is 8. That's just extraneous information. If we know it's equilateral, we know this degree right here, this angle is 60 degrees, and whatever the measure of this angle is, the measure of this arc that is created by that angle is the same. Then the last thing that we will learn is about arc length. Now, a second way to measure arcs is to measure the length of the arc, which is found as a portion of the circumference of the circle. Recall that C, the circumference, is equal to 2 pi r or pi d. To find the length of an arc, we need to know what portion of the circumference to find, or what portion of the circle we're measuring. So when you look at this over here, we have this whole thing as the circumference, right? And here we were told that this angle is equal to 90 degrees. Well, what portion is that of the entire circle? We want to know what portion 90 degrees is of the whole. Well, of course, you know that it's 1/4 of it, right? So if you have 360 degrees and you take 1/4 of that, then what do you get? Okay? And so then from that you would be able to calculate the whole circumference. We know that this, if the radius is 4, the diameter would be 8, and so my circumference is 8. So wouldn't I be looking at 1/4 of the circumference, right? 1/4 of 8 pi. Have the whole circle circumference. I need 1/4 of it because I know that 90 degrees is 1/4 of 360. And there you go. Now I know what the length is. Just be sure you do not get the terms measure and length mixed up. Circle B, shown at the left, has a radius of 7 units and is broken into 4 equal pieces as shown. If a particle was to travel a path starting at A, down to B, over to D, around to C, and stopping at E, what is the total distance that the particle would have to travel? Well, let's take a look at this. It said start at A, okay, go down to B, whoops, my line isn't going to be straight, over to D, and stopping, go around to C, right? Okay, and stopping at E. What's the total distance that the particle would have to go? So it's going to go down here, then it's going to go over here, and then it's going to go around there, right? And they said that a radius of 7. So I know that this radius is 7 here. I know that that radius is 7, right? I know that my diameter would be 14 because it would be 2 of these. So what would my circumference be? If my diameter is 14, what is my circumference? Okay, it's 14 pi, right? 14 pi. But when I'm looking at this, do I need the entire circumference or do I just need half of it? I just need half of it. And then I already know that I'm going here for 7 and there for 7. So that's how you're going to find your answer. You do the math and come up with the answer. I think we have just one more of these exercises, these practice problems. A patio is created by combining a square and a circle as shown. The radius of the circle is to be 8 feet and the entire shape is to be outlined in flagstone blocks. All right, so let's get our bearings here. They said that the radius of that circle is to be 8 feet. So let's start right here with the radius. That's 8. What would the diameter be? It would be another 8, right? Oh, look here. Now we've got our square here. So just in finding the diameter of that circle, we've also found that this side is 16. It says it was a square, right? We would know that this is 16. We would know that this is 16. And they want to know how to outline it. And people, this means they're going to build a little brick walk or something like that. So they're asking for this. They want to outline that whole thing. This right here, they're not going to do anything with, and they're not doing anything with that. They just want to know what the linear distance is around the whole thing. Well, we've already got 16, 16, and 16. Add that up. And then, of course, when we find the length of the arc, that's going to be different. So you're going to have 2 sets of numbers. And so if this diameter was 8, the whole circumference would have been what? 8 pi? No, the diameter wasn't 8, that was the radius. The whole diameter is 16. So the whole circumference would be 16 pi, right? But we don't want the whole thing. We want only from here to here, okay? So you go ahead and figure that out. Now you're going to have a whole lot of problems besides these. These are not the only ones that you've got in your work. I want you to go ahead and finish all of those problems, and then when we get back to our online meeting, you mark the ones that you had trouble with, and there are going to be some that are difficult. So I'm just telling you that right now, and mark them. And then when we get together on our meeting, we'll go over them and talk about them and clear up any kinds of questions that you have. So I'll see you in a day or two because we meet twice a week. Thanks. Bye-bye.